Hi ladies, today in class we're going to go over the last material that will appear on your exam tomorrow. This is Chapter 1, Sections 8 and 9 from the textbook. 1.8 should be a bit of a review for some of you. If you've ever learned about the coordinate plane, you know that the coordinate plane is bound by two axes, the vertical axis, also known as the y-axis, and the horizontal axis, or the x-axis. By treating these two axes as a series of points, we can actually plot points in between them, and we call those points their coordinates. So let's take, for example, point T in the right-hand corner here. Point T sits on some value of the x-axis and on some value of the y-axis. We can state its location as a series or as a coordinate. We always write its x-axis coordinate first, so it's sitting at position 5 along the x-axis, and it's sitting at position 2 along the y-axis. So we separate that with a comma. We put the x position first, and then the y position second. So we can say that the point T lies at 5, 2. Similarly, if we look at point R, we can say that the point R lies at the coordinate -4 along the x-axis and -1 along the y-axis. So these points written like this are called the coordinates, and you should be able to either give the coordinates of a point that's on the graph or plot a point based on coordinates that I give you. So let's try one like that. Let's say that I give you the coordinates 1, 3, and I ask you to label that point C on the coordinate axes. You should be able to plot that by starting at the origin, taking the x-coordinate first, which I know is +1, and then moving up 3 along the y-axis. So this is where point C would lie. Let's try the same thing, but let's say I ask you to plot the point 0, -5, and I ask you to label that point D. This is a little bit different. I notice that I don't have any value for the x-coordinate, and so what that means is, rather than moving left or right from the origin, I will travel down -5. I don't have anywhere to go from side to side because the x-coordinate was 0, but I do know that I should be at -5 along the y-axis, and so point D would sit right here. Once you have some points set up on a coordinate plane, you might want to know the distance between those two points. And there's a really nifty formula for calculating the distance between two points. This is derived from the Pythagorean theorem, which some of you know and some of you haven't heard about yet, and that's okay. But the distance formula helps us to determine the distance between any two points on the coordinate plane. Now sometimes it's easy to tell the distance between two points. Let's take, for example, point D, which we just plotted, and the origin, which sits at 0, 0. If we want to find the distance between these 2 points, all we have to do is count. If I start at the origin and jump down 1 unit, 2 units, 3 units, 4 units, and 5 units, I find really easily that the distance between the origin and point D is just 5 units. Now you'll notice that I didn't make it -5 because a distance is always a positive value. So distance is really the absolute value. It's a little bit harder though if I ask you to find the distance between, let's say, point D again and now point R. That's a little bit harder because I can't just count units, because when I connect these two dots and I want to find the length of the line segment that connects them, I realize that I'm not really going in units anymore. I actually have to do some calculations in order to figure this out, and that's where this formula comes in really handy. So let's see how you might use the distance formula. Here we have two given points, point T and point R. And I'm given the coordinates for both of those points. Here I've recopied the distance formula for us so that we can refer to it. The points that are referred to in the distance formula, this x2, x1, y2, and y1, those refer to our coordinates for the points that were given. So let's say, for example, that we take point T to be our first point. That's really arbitrary. It doesn't matter which point you make the first, but let's make T the first point. Then its coordinates would be x1 and y1, because remember, x is always given first before the y. If we arbitrarily take R to be the second point, then -4 is x sub 2, and -1 becomes y sub 2. So now when we want to calculate the distance, all we really have to do is substitute in these values into the equation. And remember that when we substitute, it's always important to put things in parentheses. So I'll put x2 here, and I know that x2 is -4. And from that, I will take away x1, which I know is 5. And I'll square that quantity. And then I'll add the quantity y2 minus y1. I know that y2 is -1, so I'll put that in parentheses. And I take away from that y1, which is 2. And I'll square that. So you see, all I've really done is plugged in my values. Let's simplify this a little bit. -4 minus 5 is -9, and -9 squared is a positive 81. Plus -1 minus 2 is -3. When I square -3, I get a positive 9. I'll pick this up and finish over here. So I find that the distance is the square root of 90. Now as a radical, that can be simplified. I'll want to break this up into its component parts. I know that 9 is a perfect square that goes into 90. And so if I pull out the square root of 9, which is 3, I find that the distance is 3 radical 10. You'll notice that in A and B down here, you're asked for the distance in two ways. You're asked first for its exact value. That refers to what I've just done up here, the exact value before it's been rounded or entered into a calculator, 3 radical 10. Now, if you had answered square root of 90 for part A, you certainly would have gotten most of your points because you demonstrated that you knew how to use the distance formula. However, the fact that I asked for it simplified, and you should really always simplify a square root, means that you really need to have simplified this by pulling out the perfect square, which is 9, and rewriting the answer as 3 radical 10. So 3 radical 10 is the answer for part A. For part B, you're asked to round to the nearest tenth. And for this, of course, I would expect you to use a calculator. You don't have to do that in your head. 3 radical 10, when I enter it into my calculator, I find that it's 9.486, and so forth. I'm asked to round to the nearest tenth, and that would be 9.5. And I'll box that. That's my final answer for part B. Now you take a couple of minutes, let's pause the video here. You take a couple of minutes, try the quick check, and just like we did in the example, make sure that you give me two answers. Make sure that you give me the exact answer without any rounding or calculator, and then give me the value rounded to the nearest tenth. Try both of those and then you can check your work. Besides finding the distance between 2 points that are on the coordinate plane, you might also be asked to find the midpoint between them. The midpoint is exactly what it sounds like. It's the middle of that segment. Now let's say that we had a horizontal line given here with points A and B lying on it. And let's say that I told you that the distance between A and B was 8 units. So that they span a distance of 8 units. And then I asked you, where do you suppose this point, the midpoint, lies with respect to point A? That's a pretty obvious question. The answer would be 4 units away. All you really have to do is find the midpoint of that value, 8 units. In other words, we find the average between the final point on that line, which lay 8 units from the starting point, and the first part of that line, which lay at the starting point at the coordinate 0. And although you might not have gone through this process consciously, in your minds what you were doing was you were taking the average of 8 and 0. As you know, to find the average between two numbers, you add them and then divide by the total of number of numbers that you added on top. And since we're adding 8 and 0, that's 2 digits. So you found the average of 8 and 0 to be 4 units. So the appropriate way to find the midpoint of a line segment is to average the coordinates of the 2 points, or the 2 endpoints. That's what we'll do, except that we won't just be dealing with flat lines, we'll be dealing with lines that lay on the coordinate plane, meaning that they have both x and y coordinates. But that's okay because we just do it in the same way, just twice. So if we want to find, for example, the midpoint of line segment QS, we will first find the midpoint of the x-coordinates, and we will separately find the midpoint of the y-coordinates. And the midpoint, of course, won't just be a number in this case. It actually has to be a point. I'm going to eyeball it on this graph and say that the midpoint lies somewhere in this area. That's just an estimate. But I can't capture that estimate with just one number. It's a point on the coordinate plane, so it needs to have an x-coordinate and it needs to have a y-coordinate. And finding that xy coordinate is actually quite easy. I just have to average the x's for q and s and then average the y's for q and s. So let's try this out. This line segment QS, we're given the endpoints, 3, 5, and S lies at 7, negative 9. We didn't really need to be given those points. We can read them from the graph, but that's okay. Just like we did in the distance formula, let's sort of arbitrarily set Q to be our first point. That makes 3 our x1 value and 5 our y1 value. Then if S becomes our second point, 7 is our x2 value, and negative 9 is our y2 value. Now to find the midpoint, I'm going to find the averages of the x's and the averages of the y's. I'll start with the x's. The average of the two x values, 3 and 7, is equal to the sum of 3 and 7 divided by 2. And the average of the y's, 5 and negative 9, is equal to the sum of those two numbers, again divided by 2. And so when we simplify this, I find that the midpoint lies at 5, 2. Excuse me, 5, negative 2. And you can see that that's pretty close to what I guesstimated originally, just by sort of eyeballing the graph. It's always a good idea to do that common sense check, to make sure that your midpoint actually makes sense. So it never hurts on a test or on a quiz to just do a quick graph for yourself to make sure that the midpoint that you've found makes sense, so that you avoid any careless errors. Here's a problem that you can try. Go ahead and try the quick check at the top here, number 3. This is a good place to pause the video, give it a try, and then you can check your work. And if you answered 4, 4, for the coordinates of that line segment, you're correct. Let's try example 4 together. This one's a little bit more challenging. In this example, we're actually given the midpoint of line segment AB. We're told that M is that midpoint, which means that point B is somewhere off this graph. It's actually farther off over here. So far off we can't even see it. And then we're asked to find the coordinates of that other endpoint of point B. So this is a little bit different. We know one endpoint and we know the midpoint. We're asked for the other endpoint. So let's try this one. Using the midpoint, which I know sits at 3, 4, I'm going to write that I know that the midpoint for the x-coordinates, which I'll just abbreviate mx here, is 3. Similarly, I know that the midpoint for the y-coordinates is 4. I also know that the midpoint for the x-coordinates should be the average of those 2 points, the 2 x values. So I'm going to keep on writing this as sort of one long equation, that the midpoint for the x values equals 3, but I know that it also equals x1 plus x2 over 2. And I just happen to know one of those values. It tells me in the instructions to use the coordinates of B as x2 and y2. So I don't know what x2 is. That's a question mark right now. But I do know the coordinates of that other endpoint of point A. I know that A sits at -3 for its x value. So I'm going to fill in -3 right there for x1, and I'll leave x2 in the equation because I still don't know what the coordinate is for B. Now what you see is that I have a very simple algebraic expression, and I'm going to recopy it down here temporarily. I see that 3 equals -3 plus x sub 2 over 2. And solving this is just a matter of doing some algebra. I want to isolate x2 because that's the B coordinate that I want to know. So I will go through and I will multiply both sides by 2. So now I find that 6 equals -3 plus x2. And now to isolate x2, I'll just add 3 on both sides. So I find that x2 is 6 plus 3, or 9. And x2, remember, was the x-coordinate of point B. So I can actually start writing my final answer. I don't know anything about y just yet, but I do know that the x-coordinate of B is +9. So all this work down below here is really just some algebra. I'm going to go ahead and erase that. so that I have a little bit more room to work on part 2, which asks me to find the y-coordinate. I'll take the same approach. I know that 4 is the average of the two y-coordinates. And I know that the y-coordinate for point A is -2. I don't know the y-coordinate for B, so I'm going to keep that y2. And to find the average of those two numbers, I've got to divide by 2. So again, I'll do a little bit of algebra, and I'll carry my work down below. Multiply both sides by 2. Add 2 to both sides. And I find that y2 equals 10. So the y-coordinate of endpoint B is 10. Now I'll do a quick common sense check. Does 9, 10 make sense for the coordinates of B? Well, it's a little bit hard to gauge because I know that B is probably off the chart, but I do know that it should be farther to the right than the midpoint, and I know that it should be higher up than the midpoint, because M, after all, is the middle point between points A and point B, wherever that is. So yes, 9, 10 does make sense. Let's try another example. Practice makes perfect. In quick check number 4, we're told the midpoint of line segment xy, that the midpoint lies at the point 4, -6. We're then given the coordinates of one of the endpoints. It sits at 2, -3. Since those are the coordinates of one endpoint, I'll go ahead and make these x1 and y1. To find the coordinates of the other endpoint, I have to use what I know about the midpoint formula. And I should also break it down into its two component parts, the x midpoint and the y midpoint. I know that the x midpoint, which in this case equals 4, that's given to me, is equal to the average of the two x coordinates. I know that the first x-coordinate, x sub 1, is +2. I don't know the other x-coordinate, so I have to leave that unlabeled. And to find the average of those two numbers, I of course have to divide by 2. I'm going to skip the algebra in this step, but to isolate x2, I'll multiply both sides by 2 and then subtract 2 from both sides, and so you should find that x sub 2 equals 6. Now I'll do the same thing for the y-coordinates. I know that the midpoint for the y-coordinates is equal to 6. Again, -6. That's given to me. I also know that that -6 represents the average of the two y-coordinates. The first y-coordinate is -3. The second y-coordinate is unknown to me, so I'll keep that labeled y sub 2. And to find the average, I have to divide by 2. Again, I'll sort of skip over the algebra, but when you do the algebra and isolate y sub 2, you should find that it's equal to -9. And so here I've solved for the two coordinates of point y. The x-coordinate is 6, and the y-coordinate is -9. I'm going to do a very, very quick common sense check here to make sure that that answer makes sense. It's a little bit harder in the quick check because I wasn't given a graph like I was in the example problem, and that saves me a little bit of time. But let's see what I might do if I wanted to check this common sense just really quickly. I'll start by plotting point X that sits at 2, -3. That's around that area. The midpoint is at 4, -6, which is right around here. And so I know that the second point should be right around here, which means I'll have to move over a little bit farther to the right than I was from the midpoint, and I did. I moved from 4 to 6. And I also had to move a little bit farther down from the midpoint, which I did. I moved from -6 to -9. So 6, -9 certainly passes the common sense check for this midpoint. The last thing we're going to cover before tomorrow's exam is a little bit about perimeter, circumference, and area. And before I start, I just want to let you know that these equations, everything that you see in this box, starting with the perimeters and going through the areas, will be given to you on the exam. So you don't have to go back and start memorizing formulas. These will be given to you on the exam. Your performance on the diagnostic told me that most of you have done things with perimeter and area before. In fact, all of you knew what I meant by perimeter and area on the diagnostic test. So I think that this will mostly be review for you. The perimeter, of course, refers to the length around a given shape, whether it's a square or a rectangle or a circle. For a circle, we give it a special name. It's called the circumference, but it essentially means the perimeter. And then the area is the space that's filled up by the shape. So let's try the quick check here. We're asked to find the perimeter of a picture that is 6 inches by 7 inches. Well, the fact that this is 6 inches by 7 inches tells me that it's a rectangle. It's not a square because otherwise all the sides should be the same size. So for part A, I have to use the formula for the perimeter of a rectangle, which is 2b plus 2h. If you learn to do this with length and width, that's totally fine. You could absolutely rewrite that as 2l plus 2w, and that's up to you. But I'll use the formula that we're given. It's sort of arbitrary as to what you set as being the base and what you set as being the height. So I'll make 6 inches the base and 7 inches the height, so that when I plug those into my perimeter equation, I get 2 times 6 plus 2 times 7. That's 12 plus 14, or 26 inches. Notice that I do want to provide the unit since I'm given one. Part B is a little bit more challenging. In Part B, we're asked to find the perimeter of the outside edge of the frame. Now in this case, we have to use this given information here, that the frame is 1/2 inch wide. So let's think about what that means. We've got a picture frame, we have a picture that is 6 units by 7 units. And the picture frame is 1/2 inch wide, meaning that it extends an extra 1/2 inch on every side. Now, I'm not going to draw this to scale, but you all understand that a picture frame surrounds the picture. And in this case, it's adding an extra 1/2 inch on each side, which means if I want to label the base and the height in this new picture frame, I have to add a 1/2 inch here and a 1/2 inch here. So the new height wouldn't be 7, but it would be 8. And I have to do the same for the width. For the width, I'd have to add a 1/2 inch here and a 1/2 inch here. And so the new width would be 7 units. And so these values, the 7 and the 8, these are what I go and plug in for the perimeter of the outside frame. So I'll fill in 7 for the base and 8 for the height. And that's 14 plus 16, or 30 inches. Let's try something similar, but now we're doing the circumference of a circle. And we're introduced here to the value of pi. We'll actually explore pi in a little bit more detail later on. For now, it's enough for you to know that pi is equal to the circumference of a circle divided by its diameter. And what's really cool about pi, the reason why it gets so much attention, is that pi is the same for absolutely any circle. For any circle, you can take its circumference, you can divide it by its diameter, and you will always get 3.14159, and so on and so forth. It's always the same number. Using this definition of pi that I've just given you, you can actually do a little bit of very simple algebra in order to figure out how you might find the circumference of a circle if you know its diameter, as we are in example 2. We're given the diameter, that it is 12 units, or 12 inches. And I'm asked for the circumference, first in terms of pi. Well, doing a little algebra, in the equation given up here, if I want to isolate the circumference, I simply multiply both sides by the diameter. And in fact, that's the formula for the circumference of a circle. Circumference equals pi times diameter. So for the first part of this question, where I'm asked for the circumference, it's really as easy as writing 12 pi, and I always give units when I can, inches. Easy as that. In the second part of this question, I'm asked to give this circumference to the nearest tenth. So for this part of the problem, I will use a calculator. You could certainly do this by hand if you rounded pi to 3.14 or so. I'm using a calculator, and I find that this value is 37.68 ... And so when I round that to the nearest tenth, it becomes 37.7 inches. So given these examples, I'd like you guys to try these two quick checks, numbers 2 and number 5. This is a good point to pause the video. You can try it out and then check your work. Here you have the solutions to part 2. And let's take a quick look at part 5 together. Here we're asked not for perimeter, but actually for the area. And so we need to use a separate equation now. The area of a circle is always equal to the constant pi times the radius of the circle squared. So to plug in for part A, again I have pi. I'm not actually given the radius of this circle, I'm given the diameter. So to find the radius, I have to take that diameter and halve it, so that is 2.5 squared. I'm asked for this answer in terms of pi, but I still do have to multiply out the 2.5, which is actually pretty easy if you remember that 25 squared is 625. So this becomes 6.25 pi feet squared, since we are dealing with area. We have a square unit there. Of course, if you didn't know that 25 squared was 625, you could use a calculator for that. And then let's try 5b. We're then asked for the area to the nearest tenth. This just requires that we take our 6.25 and actually multiply by pi in our calculators. And that gives me 19.63 dot dot dot. Rounded, that becomes 19.6 again feet squared. And finally, this is our last question for the day. This is a PSAT practice question. It's multiple choice style, and so we're asked to find the area of this figure sitting to the right. Well, it's a little bit tricky because this particular shape, I can't really describe it, doesn't really fit any of the categories that we've learned previously for shapes for which we can find the area. But you'll notice that it actually is a conglomeration of multiple rectangles. So I'm noticing that I can divide it up into smaller shapes, and I actually do know how to find the areas of all of those. What I'm looking at now are 3 rectangles. The first rectangle, I'll call it A1, has an area equal to its length times its width. Well, its length is fairly easy, that's 6 centimeters, but I don't know this value offhand. What I need to do is notice that this side here, marked with a single tick mark, is equal to 2 centimeters, or measures 2 centimeters. That means that any other side of this shape that has that single tick mark is also 2 centimeters long. And so the width of that larger rectangle is 2. Carry this out, and I know that the area of the first rectangle is 12 centimeters squared. So I'm on my way. I'm noticing when I look at the answer choices that that the first letter, or the first option, 12 centimeters, is equal not to the area of the entire shape, but as we just found, 12 centimeters equals the area just of that first rectangle. So I'm going to cross out option A. I know that can't be right. Now I'll take a look at the second rectangle. I'll label that A2. The area of the second triangle is also equal to its length times its width. Now this is a bit challenging. I don't know offhand, or nothing is directly given to me about its length or its width. But I can do a little bit of critical thinking here. I know, for example, that this entire side, which includes a little bit more than the length of A2, is equal to 6 because it's congruent to this line segment up here. I also know that this little subsection is equal to 2 because it has the little tick mark, which I've pretty much covered up there. So if the whole side is 6 and that little section that I should snip off is 2 units, then the length of A2 is simply 4. The width, just like we saw in the first rectangle, is 2, and I know that because this side here has the tick mark. 4 times 2 is 8, so the area of that second rectangle is 8 squared centimeters. Now it's just a matter of finding the area of that very last section of my shape. I'll call that A3. And this isn't actually so bad because I know the length and I know the width. They're both marked with the tick marks. Both are 2 centimeters. So I'm using the equation for a rectangle. You could also actually use the equation for the area of a square here, that the area of a square equals the side squared. Either way of approaching this problem would be fine, because in either case you get that the area is 4 squared centimeters. Now, of course, if I want to find the total area of all those smaller shapes combined, I need to add them together. And that gives me 24 squared centimeters. So B is the correct answer here. Okay, so that's all of the material for today. Tomorrow on your test, remember that it'll cover everything starting on Monday and going through the end of class today. And I also want to let you know that I'm giving you several formulas. So let me make a quick note here of the formulas that I'll give you on the exam. They include all three perimeter formulas. And by that, one of them, of course, is a circle. So I have the perimeter of a square, perimeter of a rectangle, and the circumference of a circle. I'll also give you the formulas for finding the areas of all of those shapes. I will give you the distance formula that we learned today, and I'll also give you the midpoint formula. Now eventually you will have to memorize these formulas for your geometry class during the school year, but since we're on sort of a short time schedule, I don't want to make you spend a lot of time memorizing things. I'd rather that you spent your time really knowing how to do these problems. So your homework for tonight is 2 worksheets. It's 1.8 and 1.9. Please notice that on worksheet 1.8, you don't have to do all the problems, just numbers 1 through 19. So don't go beyond number 19 on that first worksheet. All right. So students often ask me how best to study for the test tomorrow. I would recommend going over your old homeworks. Certainly go over the quiz that we took on Wednesday, which you're getting back today. Make sure you know how to do all of those problems. If you need any help, see the substitute, and I will see all of you next week. Have a great time taking the test tomorrow, and a really wonderful weekend.